Let's talk about the calculation of the derivatives. Before the calculation, we have to know that we can differentiate only continuous functions. We have the theorem: if our function f has a derivative at some point x equals c, then the function f is continuous at this point x equals c. So our function is continuous at every point where it has a derivative. For the calculation, we can have the following notation. We can write df of x over dx, or df of x by dx, or we can write f prime of x. Let's look at the differentiation rules. Derivative of a constant function. If our function f is a constant, then the derivative of a constant equals 0. Derivative constant multiple rule. If u is a differentiable function of x and c is a constant, then the derivative of c times u equals c times derivative of u. Power rule, general version. If n is any real number, then the derivative of x to the power of n equals n times x to the power of n minus 1 for all x where the powers n and n minus 1 are defined. Derivative sum rule. If u and v are differentiable functions of x, then their sum u plus v is differentiable at every point where u and v are both differentiable. At such points, the derivative of the sum u plus v equals the derivative of u plus derivative of v. Let's look at this example. Differentiate the following powers of x. Here we can use our power rule and we can calculate everything. So if we take this x cubed, we just decrease the power of x and use this 3 as a constant before x. So we explain this 3 times x squared. If we take this x to the power of 2 over 3, again we use this 2 over 3 as a constant before x and decrease our power of x, and finally we obtain this 2 over 3 times x to the power of minus 1 over 3. The same procedure for the x to the power of minus 4 over 3, and we obtain this minus 4 over 3 times x to the power minus 7 over 3. And equivalently, if we take this 1 over x to the power 4, we can use this rule and obtain minus 4 times x to the power minus 5, which is minus 4 over x to the power 5. Let's look at our second example. Find the derivative of the polynomial y equals x cubed plus 4 over 3 x squared minus 5x plus 1. So to calculate the derivative, we can use our summing rule. It says that we need to take the derivative of each term. And then we can use our power rule to find the derivative of x cubed, which is 3x squared. Then we can use our constant multiple rule to find the derivative of 4 over 3x squared, and this will be equal to 4 over 3 times 2x. And then we can use again the power rule, and we can see that our 5x becomes just 5. And then we use our constant rule, which says that derivative of the constant is 0, so our 1 after differentiation becomes 0. And finally, we have 3x squared plus 8 over 3x minus 5. Let's look at this example, and by this example I'd like to show that it is not necessary to use the notation dy by dx, so we can use the notation y prime, and actually we have this polynomial, we can put it inside of the brackets and write this prime again and to calculate our derivative. Now let's study how to differentiate the exponential and logarithmic functions. If we have the function y equals ln x, our derivative will be equal to 1 over x, and we need to define our x greater than 0. If we have the modulus of x, we will have the same result, 1 over x, and we define our x as not equals 0. For the functions y equals e to the power of x, our derivative will be the e to the power of x. So if we take 5 e to the power of x, our derivative will be the 5 e to the power of x. If we take ln to x, we can use actually the logarithmic rules, and we can express this ln to x as ln x plus ln 2, and we know that this ln 2 is a constant, so the derivative of that will be equal to 0, and finally we will obtain 1 over x and define again our x greater than 0. And actually if we take another constant, for example 3 or 4 or 7, our answer will be 1 over x again, and we can note that whatever constant we can take c, our answer will be 1 over x. For our general cases for logarithm and exponential functions with the base a, we have the following rules. The derivative of log x with the base a will be equal to 1 over ln a times 1 over x, and the derivative of a to the power of x will be equal to a to the power of x times ln a. What also can be useful when we will operate with derivatives? If we have u and v and we need to calculate the product of them, we can see that the derivative of u times v is equal to u times derivative of v plus v times derivative of u. For the derivative of a quotient, we have this rule: derivative of u over v equals v times derivative of u minus u times derivative of v, and all is divided by v squared. Also, we can use the differentiation rules for trigonometric functions, so we can calculate according to these rules the derivatives for sine x, cosine x, tangent x, and cotangent x. I hope you will enjoy the differentiation and use and apply the derivatives of different functions. Thank you for attention. Bye bye.